So this is from figure 5.3 in your textbook. So please look at your textbook. Okay, so first we look at A. Okay, this is A. Table of surface water profiles for mile profiles. So we have three types. First, okay, how do we classify this? Either 1 or 2 or 3 is depending on the depth range. Okay, it is depending on the depth range. For example, in this case, YC, critical depth, is the shortest one and follows by normal depth, and the flow that we are interested with is this Y. Okay, let's write it here. Okay, so this is YC. Okay, so this is YC, and this is the second, the third from bottom, this is Y naught, and this is Y, the profile that we will study. Okay, so this is, obviously, this is the bottom of the channel. Okay, I'll repeat. In this situation, when YC is the least, has the smallest depth among these three, so in this category, the profile name is known as M1. Okay, so always look for this depth range to determine the category, the profile name. Okay, so in this case, dy over dx, which means the depth over the distance, is positive. Okay, how can we see this? Okay, so you can see that this is the profile that we are interested with, this y. So as it goes to x direction, the depth increase. See? Okay, so since the depth increased, so we immediately know that the energy increased towards x direction. Okay, so for this case, we also know that since y is more than yc, the Froude number will be less than 1, because this is also known as subcritical flow. Yeah, because your y, normal y, and y is more than yc. Okay. Okay, because yc, since yc is more than, okay, let me erase this. Okay, the Froude number, because you always know when yc is less than normal y, then we normally will get subcritical flow. Okay. Okay, so let's look at the category of M2, profile name M2. So in this profile, you can see that YC is less than Y, the profile here, but Y is less than Y normal. Okay, so let's have the label here. Okay, so this is YC, Y critical, and this is the clear black line is the flow profile. Okay, and these dotted lines up is the normal depth. Okay, so under this situation, the profile name is M2. And you can see that the depth, as the depth goes towards x direction, the value is negative. See? And also, we know that the energy going to this direction is also negative. Okay, so since in this case, the critical depth is also the least has the least depth among these three. So this is also subcritical flow. Okay. Okay, in the third case, the profile name M3. So this is different than the other two. Okay, so your profile, I mean the flow profile that we are interested with, is less than critical depth, and this critical depth is less than normal depth. Okay, so this is the thick line is Y, so the small dotted lines is YC, and the first one is, the top one is YO. So in this case, you can see that the profile is moving towards positive direction, so it increased the value, which is why you have positive here. And then the energy is, when it goes to the positive value, so the energy is negative. Okay, so if you want to know about this, you have to look at the energy line, like this. Okay, so this is Y and this is E. Okay. Well, since Y increase, which means it goes into this direction, to the left direction, because Y increase to the left direction. But when Y increase to the left direction, E will decrease. Okay. Okay, in this case, the Froude number is more than 1, which means it is supercritical flow. Okay. Okay, so it's the same here for steep profile. Okay, let's immediately draw this. Okay, so this is so this is normal depth, Y naught, and this is critical depth, YC, and this is the depth of the profile. This is Y that you will determine, because in most cases, Y, normal depth and critical depth will be given, and you have to find the profile, this depth. Okay, yeah. Okay, in this case, since normal depth is less than critical depth, so this is under the category of steep profile, steep ridge. Okay, so if you from here, you can see that the depth increase, so which is why you have positive, and then surely the energy will increase, and then under this category, the flow will be subcritical flow. Okay, okay, this is how you understand this, how to read the profile taxonomy. So whenever you are trying to solve the problem, so you have to identify what kind of profile, so you can always refer to this figure. Okay, so you can try yourself for the rest of the profile. Okay, so this is the profile for critical profiles. Okay, where you have Y naught, normal depth is equals to critical depth. Okay, you can see here, all this profile has normal depth equals to critical depth. Okay, so also in this category. So you can also try to understand this, like what I told you from the previous slide. Okay, this is horizontal, where you don't have any slope. Okay, you don't have any slope, so it's just go horizontally. Okay, and this is adverse. Like I told you, adverse is going to this direction, to up direction, adverse direction. So you can see that the slope is not like this normal, but it goes up like this, yeah, for the bottom slope. Okay, of course the profile can go either down or upwards. Okay. 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 When we are talking about stream profile, we are also concerned about stream obstruction. Because stream obstruction, like sluice gate, upward step, and constriction, they have influence on the flow profile. Okay, you have seen this before, right? Previously. I mean, in the previous video. Okay, so what are we going to do? We are going to explore a single ridge with upstream and downstream boundary condition of normal depth. Okay, so within the ridge, we place one of the obstructions. So we will put either sluice gate, step, or constriction. Okay, so the same energy and momentum rules learned earlier will still apply. Okay, but now we have the added realism. What is the realism? That the inclusion of friction. So we have to include the inclusion. We have to include the friction, and surface water profiles contribute to the analysis. So what I can say here is that the energy and the momentum rules will apply. So you will use the same formula like you used before. So nothing new about the formula for these types of problems. Okay, so that I put here two pictures. This is just like an example. So first, this is like an upward step. Okay, so this is like upward step. Upward step. But anyway, this is actually a broad-crested weir. Broad-crested weir. So inshallah we will learn about this later. But okay, this broad-crested weir also looks like this upward step. So this upward step will change the profile of water here. You can see here. This is colored in blue. I believe this is about velocity. Maybe, oh no, this is about pressure. Yeah. So how it classify the pressure in these types of flow. Okay, this is in green color, and this is in red, yellow, and green, and here we have some blue. So if you are interested to know what these colors mean, you can look at this publication. Okay, this is about flow patterns of the broad-crested weir flow when the water level 10 meter, and this is under the category of pressure. So this is taken from this publication. Okay, I just want to show you how the profiles can change when we have this kind of obstruction. Okay, in this second figure, this is actually a sluice gate. Okay, this is a picture of a sluice gate in a dam. Okay, a dam. Okay, this is taken from this website. This is at somewhere in Japan. Yeah. Okay, at Nokui Dam. Okay, what it says for this figure is that spectacular 30 meter per second. You can imagine how fast the water flows. Discharge of water when the sluice gate are open daily at the 156 meter high dam. So this is really huge, really high dam. This is the second highest in Japan. Okay, this is during May 2018. This is in 2018. Okay, to get ready for the increase in rainfall expected during the coming rainy seasons. Okay, so this is kind of water profile that exists. Okay, what happened behind the dam we cannot see, but this is what happened when the sluice gate is open. The flow gushes in this 30 meter per second velocity. You see. Okay, this is all for this slide, and then we will do some examples. Maybe I will split this example in the next video, so I will see you in the next video. Thank you, bye.